Okay, next I'm going to open our salary survey data. And here it is. Call it something sensible. Salary survey. And hit run. And there's our data. Several columns of data, a couple of missing values, and our salary is what we're going to be trying to predict. Okay, so let's load up a regression model. Under tasks, linear models, linear regression, change our data set so we're working with the correct salary survey data. Dependent variable is salary. This time we've got a couple of classification variables, major and gender. And just in case you hadn't noticed, you can actually tell that these are classification variables by having a look at the little icon next to the variable name. So we've got this little upside down kite, upside down diamond with what looks like an A in it. I'm not really sure why it's that. I think A because that's a typical label, is to label things with letters, as opposed to the circles with the 1, 2, 3 in them, indicating continuous variables which have to take numerical form. Okay, so we'll stick our major and gender variables in as classification variables. Scroll down here, under continuous variables. It looks like we've got 5. We've really only got 3 new ones. We've got major and gender code that have been coded as 1s and 0s instead of leaving them as, say, M and F for male and female. So we could use those instead, and if we wanted to do that, we'd actually be free to put them in as continuous variables. But we're just going to go ahead and add in usefulness, GPA, and years of experience. Next we head over to our model tab. We've got to enter all of these things into the model, so we'll select them all and add. Scroll down, hit OK. Alright, we're going to go ahead and run this model and see what sort of output we get. Alrighty, let's take a look at it. We have 22 observations read, 20 used. Why is that? Because we had 2 missing values. Scrolling down, we've got 2 levels for each of our classification variables. For major, we either have arts and science or business. For gender, we have female and male. And here are the details from our model. We have an overall significant model, which is a good thing. P-value for the overall test of validity of the model, the global F-test, is very, very small, less than 0.05, so we believe this is an adequate, or this is a model that we can learn something from. It's not completely useless. We have a very high R-squared. Honestly, there's an unrealistically high R-squared for this type of data, which suggests that it says very probably artificial, fake data. What's next? Well, the meat of our output is this parameter estimates table. And what this shows is which of our variables are useful in predicting salary in our data, and what sort of effect they have on salary. We ignore the intercept, and we skip down to the next one, usefulness. Usefulness, turns out, is not useful. It has a very high p-value, much, much larger than our 0.05 threshold. So from this, we would understand that usefulness is not a useful variable for predicting salary. Usefulness was a survey variable where we asked these graduates how useful they found statistics in their job. Turns out that in this data set, it was irrelevant to salary. Continuing down, we have a surprising one here. We've got GPA next, your grade point average. Turns out to be significant in this model, p-value less than 5%. And then once we see that, we have a look at its estimate, and well, it's bad news for people like me, bad news for our professors. It turns out that this has a negative coefficient. So what does this mean? It means as GPA goes up, salary goes down. Yeah, don't repeat that outside this class. I don't think any of your professors are going to be happy with that result. But let's bear in mind this is fake data, so don't read too much into it. Next up, we've got years of experience. This one is very, very significant. P-value less than 1 in 10,000. So we're very confident that years of experience has an impact on salary, probably as you would hope, right? And what is the effect, at least in our model, for every 1 year that for every 1 year that experience goes up, for every extra year of experience, our salary goes up by $6,114. Wish I got raises of $6,114 each year. Moving on. Next one, we have our major. Again, very, very significant. And what does it say? It's saying that arts and science majors make $6,617 less, because of that negative sign there, than business majors. Well, good thing we're doing a business degree. Finally, we've got the gender variable. This one's not quite significant, so we should be reluctant about using this variable in our model, but what do we see? If we called this one significant, we would say that women were earning $3,288, or about $3,300 less than men, after taking into account all of the other variables that we have looked at up there.